Hey, there's this Math 7, Unit 5, Lesson 11, dividing rational numbers. So we're going to be dividing signed numbers today. So first of all, let's consider some equations. We have negative 27x equals negative 35. So without computing, is the solution to the equation going to be positive or negative? In this case here, without looking at it, if I'm going to move this over there, I'm going to end up dividing by a negative 27. So when I have a negative divided by a negative, I'm going to end up actually with a positive solution there. Are either of these two numbers solutions to the equation? Well, 35 over 27 becomes a positive, so we would say that actually that one becomes a solution to the equation. I probably could reduce a little more, but that would actually be my starting point for this problem here. When it comes to finding the missing values in the equations here, it's important to recognize that sometimes you have positives and negatives working together or mixed up or not mixed up at all, and you have to know what the outcome is going to be. So a negative times a positive is going to be a negative solution, and I look at 3 times 4 as being 12. Over here, because I have a positive answer, I need to multiply by another negative number because I'm already having one there. So my negative number that would work in this case would be a negative 4. Negative 3 times negative 4 gives me a positive 12. Here, because I'm ending up with a positive solution, I have a positive number already, so I can just multiply by a regular positive number to have 3 times 4 equals 12. Here, again, a positive number there, so I'm going to multiply by a negative, so that a negative times a negative equals a positive. And finally over here, because I have a negative solution, I'm going to have a negative 3 times a positive 4 to get there. It then asks you to then rewrite the unknown factor problems as division problems. So let's take a look at what that would look like. Okay, I'm going to draw some lines out here. So writing them as division problems, let's take negative 12 and let's divide that by, in this case here, a 4. That could work. And we're going to say it's going to be equal to negative 3. Here we can take our 12 and we'll divide that by a negative 4, and that's going to equal negative 3. This one is a 12, and we can divide it by a positive 4, and that's going to equal a positive 3. A 12 divided by a negative 4 equals a negative 3. And then a negative 12 divided by a positive 4 equals a negative 3. Okay? And so, what we're seeing here is that a negative divided by a positive equals a negative, right? And a positive divided by a negative equals a negative. So when the signs are different, we end up with a negative solution, right? Different there. When they're the same, when it's a positive divided by a positive, we end up with a positive. And we have this is an example of a positive divided by a negative, which we've already done, equals negative. This is a negative divided by a positive. So what we didn't have listed here is you could also do a negative divided by a negative, and that will also be a positive. We didn't have one. We could rewrite this one if we chose to. We could say it's negative 12 divided by the other number, negative 3, and get ourselves a positive solution. So that'd be an example of how you'd have a negative divided by a negative equals a positive there. All right? So when you take a look at the next page, they're really just asking you that same thing to complete the sentences, which is what we just did. Okay? So complete the sentences. The sign of a positive number divided by a positive number, so positive divided by a positive number, is always positive. A positive divided by a negative is always negative. Negative divided by positive is always negative. And then negative divided by negative is always going to be positive. All right, let's take a look at a little word problem. It says Han and Claire are walking towards each other at a constant rate. Okay, so they're walking towards each other. So one is walking this way and one is walking that way at a constant rate. They meet up and then they continue past each other. So not only do they go this way, they eventually meet each other and then walk past each other. Okay. So as they're going along, they cross each other like so, like that. We'll call the position where they meet up at 0 feet. So we'll call this 0 where they happen to cross each other up at. Okay? And the time when they meet, 0 seconds. Han's velocity is 4 feet per second. So since that's going the positive direction, let's call this Han, and we can say he's going at 4 feet per second. And since this is Claire and it's going -5, we can say this is Claire over here going -5. So Claire is the arrow going this way, and Han is the arrow going that way. Where is each person 10 seconds before they meet up? So like we've done before, we're going to take, for Han for example, we're going to take his velocity, which is 4, and multiply it by the timing we're looking at. Now 10 seconds before actually is going to be a value of -10, because before he gets to 0. We're before there. So 4 times a -10 is going to put him at -40 for the location there, -40 feet. Which makes sense, because if he's going this way, before he gets to the meeting point, he's going to be located somewhere over here, which is in the negative side of the world, right? But for Claire, Claire is going -5 feet per second, and 10 seconds before she meets up, that'd be a -10, right? So here's Claire. So somewhere over here, we can see that value is over here in the positive side of the world. It's going to give us a +50 is where they're going to be. So the question then becomes, when is each person at the position -10 feet from the meeting place? When is each person at -10 feet from the meeting place? Okay, so in this case here, we're looking at where is, when will Han be about here? Okay, and then when will Claire be about there, about 10 feet away from where they're going to meet? So for Han, we know Han is traveling 4 feet per second, right? So we know he's doing 4 feet per second. Okay, so we want to see where he's going to be, and how many seconds it's going to be for him to get to the place where we're at -10. So for him, we're going to do -10 feet, okay, and we're going to divide that by 4 to see what we come up with. In this case, we're dividing by 4 because that's how fast he's going, and that's going to be -2.5 will be his location. For Claire, Claire's going at 5 feet per second, right? Okay, and so what's happening here is that Claire's going to do a -10 divided by a -5 to give us a time be at location of 2, position at 2. So we have -2.5 and 2 is where they are, -10 feet from the meeting place. That is when they're going to be there, that many seconds before. Okay, so there is those two folks there, and that's the idea. Let's move on to drilling down. I don't think I explained that last one very well, but I'm just thinking about it in my head. Sorry. Well, let's move on. A water well drilling rig has dug to a height of -60 feet after 1 full day. Assuming the rig drilled at a constant rate, what was the height of the drill after 15 hours? Okay, so for our drill, it's going at a rate of -60 feet in 24 hours. We want to find out where it was at 15 hours. I can reduce this rate down first of all if I wanted to, just because it's a bigger number. I may not want to play with a big number there. I could, but that is the same as, again, we can cut this in half. This becomes -30 over 12. I can keep cutting it in half to have -15 over 6. I can keep reducing because 3 goes in here 5 times, and 3 goes in here 2 times. We have -5 over 2, and maybe I want to stop it there, or I want to go down and say, well, how much is it in 1 hour? We're going down -2.5 every 1 hour. Now, with that in mind, okay, we can see how far is it going to go in 15 hours, and we can set up a proportional relationship here. So 15 times -2.5 is -37.5 is what our x value is going to be. So at that same rate, 2.5 feet down per hour, it would get down 37.5 feet below the surface. If the rig is running constantly and is currently at a height of -147.5, how long has it been going? Well, we know that it's going at a rate of -2.5 every hour. So we want to know what that hour rate is going to be in order to tell us that we're at a spot of -147.5. So I'm going to divide by -2.5, and -147 divided by -2.5 tells us that it's going to be happening at hour number 59. Again, it's positive because a negative divided by negative is a positive answer there. So using the coordinate grid on the next page, we want to show the drill's progress. So we have some points, right? We have a point at negative, well, that's what our points are. Our points are at 15 hours, we've gone 37.5. So here's 15, and we're going to go 37.5. We're going by 25 here, so we're somewhere around there at 15. We know that at 60 and 24 hours, we go 60. So 24 is here, and we're going to go 60, so somewhere about there. Okay, that's my 24 comma 60. This is my 15 comma negative 37. Okay, and then we also had, in our case here, we had 59 hours is at negative 147, so somewhere down here, right? So that's what my graph would look like. Has to start at 0 because we have to start drilling at nothing. That's where we're going to start from. So I'm going to make it go to the origin here, and we're going to draw this line and look something like that. At this rate, how many hours will it take until the drill reaches negative 250? So again, we can take a look at it and we can see that it looks like, we continue here, it looks like it's going to take somewhere a little over 105 hours. So our estimate might be 105 hours or so, looking at our chart here, something like that. Again, it's hard to say exactly, but we could also find out for real. We could do our rate, so we can say that at negative 2.5 times how many hours is going to take me to get to negative 250. So when I divide by negative 2.5, we find that the answer should be 100. So I'm off a little bit of my estimation because my graph is not perfect, but that's the actual answer there. All right, let's take a look at tonight's homework and see